Welcome back to the channel. I hope you guys are doing amazing. So, in today's daily challenge on Leetcode, it is a very simple take not take version of knapsack DP, which I have explained multiple times in my DP playlist. Okay, so if you are following my DP playlist, definitely you should try this problem on your own first, because this should definitely be done by you. Otherwise, if you want to learn DP from very basics to advanced, you can keep following my DP playlist. Okay, and if you are not following, then I will definitely suggest you to follow, because the questions like this is something which we have definitely done. Okay, so let's see the question. Uh, Ways to express an integer as sum of powers. So you are given two positive integers n and x, and you need to return the number of ways n can be expressed as a sum of the x power of unique positive integers. Okay, so the result can be very large, so you need to return it some modulo 199 plus 7. So you are given an example like if n is 160 and x is 3, then one way to represent n is that 2 to the power 3 plus 3 to the power 3 plus 5 to the power 3. That makes a total of 160. Okay, so this is one way of representation. Okay, so you see if n is 10 and x is 2, then you can always represent n as 3 square plus 1 square, which is nothing but 10. Okay, and output is 1, because this is a single way. If x is 1, something like this, you can represent n as 4 to the power 1 also, which will make it 4, and 3 to the power 1 plus 1 to the power 1, it means 4. So I hope there are two methods here and which is clear to use. You see the constants are really small. So it's something like n from goes from 1 to 300 and x goes from 1 to 5. Okay, so I hope the problem statement is at least very clear to you. Okay, and the approach is also really simple if I tell you. Okay, so what is given in the question? You will be given n and x values, right? You will be given n value and x value. So you need to find something which will make this n. Okay, and it will be of the sum of powers of x. Okay, and some things like this. So how do you understand what is the maximum value which can be in my n? Okay, so what you can do is that you can make an array. You can make a array, let's call it powers. Okay, so this powers array will contain something like 1 to the power x, 2 to the power x, 3 to the power x, and stuff like this, unless this last value does not exceed n. Okay, so you can see that from x equals to 1 to 5 are only the possible choices, because that's given in the ranges 1 to 5, and within this you cannot exceed very much. You cannot exceed something very much. If you take x equal to 1, then you will end up in storing values up to n to the power 1, which will make it n. Okay, so there can be at max n elements in this power set. So I hope this will be very simple for you. So you can easily do it, right? So if we take an example, if it's at all confusing, let's take this example, something like 160 you have to make, and x is given to be 3. So what you will do in this case is that you will store 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. Okay, and you will try to store 6 cube, and then see that 6 cube is something like 216, which is exceeding this 160, and therefore you will not store this. Okay, and what you can do is that now you have this set with you. Okay, so you have a set which is something like 1 8 27, 64, 125, and you need to pick elements from this set to make it 160. Okay, so this from here it you can do a simple DP. Okay, so it will be a simple take not take DP. So what do I mean by it? You can traverse through all the elements from this I equals to 0 to I equals to this whatever this size vector of size minus 1. Okay, so you just traverse through all the elements and just check that well, if it can be added to your total answer, whether you will take or not take. Okay, so you just check, you when you are here, you just check whether you can take this or not take, whether you can take this or not take it, whether you can take this or not take it, and similarly you can just go ahead with it. So as the answer says, it will be 2 3 and 5. So 2 3 and 5. So you see that if you perform something like not take off this value, then take off this value, take off this value, not take off this value, and take off this value, then you will be taking up 8 27 and 125, which will end up in making 160. So here you get one possible way. Okay, so I hope things will get more clear as I perform the DP. So definitely I will start with recursive approach first, and then I hope you know that in order to write a DP, you should start with the recursive code first, and then you should go to the memoization, which is nothing but a recursive DP. Okay, and you can also write the tabulation approach. This is optional but very important for interview. So yeah, also the tabulation approach you can write. But this will give you an accepted case. So let's try to put all the elements as I told you. Okay, so let me have some things uh, like a vector. I will call it power. Okay, so let me call it a simple way. Okay, so what will I do is that I will just check. I will have an integer I. Okay, it will start with 1, and I will just check that while power of I to the power x. So I will be incremented I one by one, and I will while this is less than or equals to n, I will just keep pushing this answer into the n. Okay, so I hope you understand this. I will just keep pushing this power of I to the power n, and I will also increment I. So at first it will just put 1 to the power x, okay, then 2 to the power x, and in a similar manner, it will go all the way till n to the something to the power x, which is just less than n. Okay, so I hope this is very clear to you. This will be storing some things like this, and it will store till I to the power x, and all of these this definitely should be less than or equal to n. It just takes care of that. Okay, so now you have all the powers in the answer. Then now you will just iterate through these vectors, and which this vector you will just iterate through it, and you can just check whether I will take or not take. So I will follow a very standard way of take not take. Now I will not draw the recursion tree and try to memorize it and show you in detail. I hope you know this already. If you don't know, definitely follow my DP playlist. You will find the link in the description. So I will be writing this take not take DP approach. Okay. So let's see how it's done. So at first I write a calc function. Okay. Uh, I will write a calc function. It will take the vector. It will take n. It will take the starting index. It will take the total sum. So initially, it's something like you are at index 0. Okay. So it's something like you are at index 0 and you have nothing in your bag. Okay. So you have an amount. You have a total amount which is also 0. You will keep accumulating that amount and try to make it equal to n. Okay. So you just iterate through these vectors at different indices. You just decide whether to pick or not pick. If you are picking, you just add your value to this answer amount and try to make this amount equals to n. Okay, so that will be our idea. So I will just keep a vector, and I will have n, I will have this I index, I will have total amount with me, and stuff like this. Okay, so I hope you understand it. And if we have reached the end of the list, okay, so if it's something like if I goes to vector dot size, then it definitely return 0. Okay, and before this, we should also check that if this total amount is equals to this total n. Okay, so if the amount is we got that the current amount with us is equal to the total amount which needs to be done, which is n, then I will say that I have found one way. Okay, then I will say that I have found one way of performing this. Okay, so I will just return one. So it just means that just found one way. So that's how you write the base case of the recursive approach. I hope you understand it easily. And since this is sorted, I hope you understand also that this vector is already sorted, right? 1 to the power x, 2 to the power z, this is all sorted. So if you cannot take one element currently in your amount, then definitely you cannot take the further elements also. So if you get something like if you add amount to the current element, okay, the current element, let's say is wake of I, and if you cannot add this, what does it mean? If it somehow exceeds n, then also you return 0, because there is no possible way that you can make it n right now. Okay, so if you would have made it n, you would have returned 1 already, and if you are reaching the last index, so you have no more elements to take, then you also return 0. And if you cannot accumulate any more elements into your n because it will exceed your size, then also you return this similar thing 0, because if you go any further, you will end up in getting more larger elements which you cannot definitely take. Okay, so now you can do a simple take not take. So whatever I am doing is a simple take not take DP template. Okay, if you, even if you can't understand anything, if you just know the template, you will be should be able to solve this take not take. There should not be any difficulty in this. So what will happen if I choose to take my current element? Okay, so I will be in vector, I will go to the next element I plus 1, and my amount will get added with vector of I. Okay, I hope you understand this. And what if you do choose not to take it? If you are not taking it, definitely still you will go to the next element, and you will end up in having the same amount without any increment. And you can just do simple all the ways. This, what does this take means? At the current position, if I take the current value at the current position, what can be the possible way? How, if can I get amount equal to n? Okay, so what can be the total number of ways if I choose to take in the current position? So total number of ways by taking, and also total number of ways by not taking, will be our globally total number of ways. I hope you easily get it. And I will have a mod also here, which will be 1 in I plus 7. And yeah, that will be all, I guess. As of now, I am not performing the mod. I just want to run and show you that this solution will anyways not work, because uh, if you try to see, it gives power of I to the power n, but it will be I to the power x. So if you try to run this and check, it should give you TLE actually, uh, because of, I guess, quite obvious reasons. You see, you got a TLE because of obvious reasons, that this is a recursive approach, and recursive approach takes an exponential time complexity. So in order to get rid of the recursion tree, all you need to perform is memoization, which is also known as recursive DP. So I will not tell you much details about it, because it's a simple thing. If we just catch the values, I have told you multiple times already in my DP playlist. So what will happen is that I will just take the DP dimensions. So there are two states of this DP, right? And indices and amount. Okay. So what can be the thing is that you can have this n plus 1 and this all initialized with minus 1. So you got a 2D DP table, all initialized with minus 1 right now. It indicates that minus 1 indicates that the space is empty. So what we need to do in order to reduce the time complexity is that we must take care that this DP I amount, okay, if this is not equal to minus 1, it means that if it is not empty, then you do not need to calculate any further recursion. Okay, you do not need to calculate any further recursive approach. You just try to return it. You just try to return it, because that's already calculated. That's already calculated. It means that it's not minus 1. So you just got rid of those, and this DP of I amount, I will just store it in take plus not take. Okay, and here also I will make sure that I put the mod value, otherwise it might give me a wrong answer, right? And I will just return this DP of I amount. I will just return this DP of I amount. And yeah, that's all. That's pretty much it. If you don't know, this is the basic line and basic template which we use in solving recursive DP every time we do these three things. Okay, these three things is something we do every time. And I will just quickly write the 2D DP here also. And yeah, so I hope things will be quite simple now. I just pass the function, and if you try to run it now, it will should give you correct answer. Let's see if it gives or is there any error. So let's try to finally submit it and check if it works at all. So you see, it definitely works and also gives you a pretty good runtime complexity. So I hope this method was really clear to you. Okay, and you can do something, some more. I mean, optimizations like you can say that if n is one, you take if x is one. Okay, what is the possible number of ways which you can solve it? Okay, so you can for n is two, for x is one or x is two. I guess this you can manually calculate and just return the answer before performing all of these operations. So it will also make your time complexity a little bit faster. And you can also choose to write the iterative version of this DP. I have shown you multiple times of how to do that in my DP playlist. So yeah, I hope you should try some more fidgeting with this approach. Okay, so I hope this approach was anyways clear to you. Okay, so yeah, that's all. I guess that's all for this problem. Definitely keep practicing a lot. You are definitely going to improve that way. So yeah, that was all for this problem for today, and I hope your day goes really easy. Thank you so much.